safely separate fluids, users would have multiple butterfly valves or multiple single seat valves arranged in a double block and bleed arrangement. So that's what you see here on the left, the butterfly valve. So 3 butterfly valves, one closing off the flow of the red fluid, another one closing off the flow of the yellow fluid, and then in between you have your bleed or your vent that goes to atmosphere, so that if the seals on the butterfly valves were to fail, either the red or the yellow fluid would not cross-contaminate into the opposite line. It would go directly out to drain out that bleed. So you have your 2 blocks and 1 bleed going out the bottom. Similar scenario on the right with your shut-off diverts, just kind of a different arrangement. These single seat valves are a little bit more hygienic. Well, they are more hygienic as far as cleanable, to be cleanable in place. So that's where you would typically see that in a single seat arrangement. Downside with these is you have multiple valves and multiple pneumatic actuators that need air, multiple controls going with it, and it takes up a wider footprint when you put these all together, especially if you have multiple arrangements.
So Chris, I have a couple of questions about the double block and bleed setup. First of all, Is that something you're still seeing in plants today? Are you still seeing a lot of customers who choose to go that way?
Yes, we are still seeing some of that. In certain industries, that's the way it always has been, and they're familiar with that, so they stick with it, and they like, you know, this simple method of doing things.
Okay. And when you have the 2 actuators, I've spent most of this week troubleshooting a really simple pump card. It only has like 1 or 2 valves on it, and I'm fighting with the limit switches. So each time, each of these actuators would probably have a control top with maybe 1 or 2 switches, right? So that's 2 feedback points that's going to go back to a control panel. So you're talking about going from only having 2 to 4, basically twice as many IO points for every single valve when you use this kind of arrangement. Is that right?
Yes. Yeah. If you wanted the position feedback to know if it's open and closed. Yes.
And what sort of impact does that have on cost for like a panel? Do you have any feel for that? I would imagine it's quite a bit.
Yeah. I don't know. I mean, it depends on if you're doing just a direct communication, or if you're working on a bus network. If you're on a bus network, maybe it's not as bad, but still, you add up the extra cabling, and for your different IO points. So it certainly can add up.
Okay, cool. Thanks.
So along with these manifolds, you could also see, or with these double block and bleed arrangements, you would also see flow panels or swing panels. So this is kind of maybe a worst case example of a swing panel that can also safely separate fluid. And in this case, an operator would go up to these elbows and unfasten or unclamp one connection and go to another, and then transfer the fluid to going into a different pipeline. Another example here, this just shows that these swing panels can get very confusing. If you want to expand on it and add more process lines, it can get very cumbersome. And again, with this manual intervention, there's a high probability of bad things happening, essentially, if we look at our chart here, and uncertainty of what could happen. So sometimes these swing panels do have limit switches to make sure that the operator made the right connections, but sometimes they don't have that. So there's a lot of uncertainty of what could happen in the process, not much record of what did happen. So if something did go wrong, that it might affect the process, you can't look back and see what happened and try to correct that. So risk to the product safety, risk also to the personnel safety as well, with some of those flexible hoses sticking out.
I was just going to add, I think we actually have a couple of attendees from a customer who I was at recently, and we were spending a lot of time and a lot of money modifying actually those jumpers to put in sampling valves to do a lot of different things to make those to make the jumpers safe because people would switch over and they'd have steam on the panel, and even though they were supposed to be an interlock, they didn't do it. They might not close a sample valve all the way. Part of their procedure was they had to take a sample before making a connection or after making a connection, and the valves weren't closing all the way, so they'd leak. And there's definitely plenty of problems, especially with these more complex panels.
Right. So now we're switching to the other extreme, the kind of best case scenario of using a mixproof valve inside of a manifold, an arrangement. So this shows the ideal case of each one of these being a double seat mixproof valve, that you're able to have that safe separation all within one valve, one pneumatic actuator, one control top, and be able to process different fluids at the same time without that possibility of mixing. And in this case, we have 3 different tanks with 3 different fluids, and they're being routed through this manifold. And as these valves open and close, when the valve opens, the fluid, like in this case here, would transfer from this upper line and go to the lower line and go across here and go downstream somewhere to a filler, for example. But when the valve is returns back to the closed position, in this case here, we have that safe separation, and we can still run this green fluid through the line, but at the same time, we can clean that lower line and clean this filler down here, for example, with a CIP. So we don't need to shut down the entire system in order to clean this filler. We can keep it running and keep emptying that tank, going to other fillers downstream at the same time. So in this case, it's emptying this tank, cleaning this middle tank, and then filling this last tank simultaneously. And again, it's all doing this from a centralized location, automated control. There's really no manual intervention to it. And as part of the controls logic, you have this fail-safe system, making sure that the valves are in the right position and moving sequentially before taking the next step. And if a valve does go into the wrong position or doesn't open, doesn't close, then an alarm goes off, and either the system shuts down or someone needs to correct that action.
I have a question. So just in your experience, what are you seeing more often today? I know your control tops will often have solenoids at the valve. Mm-hmm. What do you see more commonly? Solenoids in the valve control top, or do you see them in a separate kind of solenoid panel in another location?
Yeah, with a layout like this, and what we're seeing more of the trend, it is solenoids inside the control head. So having not only the sensors, the position sensors, but also the solenoids located at the point at the valve. That just allows for then one air connection, main air supply to be hooked up to the control head. Shorter response time for the solenoids to route air into the valve itself. So that seems to be the most common.
That's cool. Yeah, I feel like it's kind of a mixed bag for us. Occasionally we'll see a solenoid panel. I think our preference though, especially as a skid builder, is to actually have the solenoids at the valve as well. Mm-hmm. We do have a question from the peanut gallery.
Yeah.
Hi, Chris, Andy. I see you talk about CIP. Are these mixproof valves able to be SIP'd, steamed in place as well?
Yeah, so yes, certain mixproof valves are rated for steam. Typically, it's a short time steam, so 10, 20 minutes allotted. So you would want to make sure that the valve that's chosen, the mixproof valve is chosen, is rated for that steam in place.
One more question here this is actually from one of Holland's very own, Jim Boo. and I think you'll probably get to this a little bit later, but are Class 6 elastomers available for those customers looking to steam the valves, especially in pharmaceutical applications?
So Classics elastomers, they are available, and it is a special order. But yeah, I can work with Jim, and we can definitely find a solution. It's more common, or in our next generation Mixproof, it's more readily available within that series.
All right, very good.
And so how do we, this gets into a closer look at a single mixed-proof valve, and the theory behind how that safe separation can occur. So it's a similar double block and bleed arrangement where we have an upper seat that isolates the fluid in the upper line, and then a lower seat which isolates the fluid in your lower line. And in between the two, we have this gap, and that's shaded in yellow here. And that gap leads through this machine channel that goes out the bottom of the valve and is open to atmosphere. So everything in yellow is at atmospheric pressure. And similar to the double block and bleed butterfly arrangement, where if one of these seat seals were to fail, your leakage would get into your vent cavity, your atmospheric gap, and go directly out the bottom of the valve and start to leak. It would not try to build up pressure and get into the opposite line and cross-contaminate.
So basically, if the valve leaks, I'm going to see it on the floor.
Yeah, so that's the other thing. It gives you visual indication that a seal has failed as well. So if you see some dripping of product, especially, then it's most likely a seal has failed in that case, and you need to do some maintenance. So here's an animation that I found on YouTube. I really like it because it shows the different steps, kind of of a traditional mixed proof valve, with your two seats, your multiple seals, so your upper seal, lower seal, and then you also have a third seal that seals off the vent cavity when the valve is open. So if a seal were to fail, there's your leakage path out the drain. When the valve opens, the seats sandwich together and move, and your vent cavity is closed off, and you're just transitioning from upper to lower line. And then you have your seat cleans. So when you want to clean around your seat seals, you can do an upper seat lift or a lower seat lift, and that cleans around the seat seal, and that CIP goes to drain. So again, these mixed proof valves are designed to be cleaned in place and completely cleaned in place. So that includes cleaning underneath your seat seal in the mast or the hidden area that it's closing against. So you need to lift this up just a little bit when you're running your CIP, and it'll rinse underneath that seat seal and go out to drain.
Does everyone do seat lift, or is that only some customers who go seat lift?
Yeah, it's a good question. Most dairies, beverage, food do have seat lifts. When you get into some of the personal care or chemicals, you may not see seat lift because they don't need to clean underneath the seat, because their product isn't gonna have bacteria growth. It doesn't need to be cleaned. It's cleaned already, or relatively clean already. So it depends on the level of hygiene that the product needs.
So if I'm like an engineering guy or something like that, I really sort of need the customer to drive that, what they're doing. It's really sort of their call.
Yeah, to some extent. And I'll show some examples. When you lay out a manifold, you can use non-seat lift valves, because the other way to clean around these seats is to completely open the valve. So if the valve is going to be open during CIP anyways, then that's a way to rinse it as well, so you don't need the seat lifts.
Got it. Cool.
So yeah, I'm running through this all very fast. Since we have a short amount of time, I could probably spend a whole half day or full day on mixed proof valves. So yeah, if you have any follow-up questions, yeah, feel free to ask. I'll try to get through them all. I do want to touch on how to lay out a valve manifold. So again, this is getting into a little bit more advanced theory on mixed proofs, but similar to the animation or the layout that we had, how do you determine the number of mixed proof valves you need in a manifold? And this is kind of a generic way to get a ballpark figure of that. So you first start out with how many supply lines you have or how many sources you have. So in our example here, we have 3 tanks. And then you multiply that by how many downstream destinations or outputs you want, or fillers. So in this case, we have 2 fillers downstream. So you would really, you would multiply that 3 times 2, and you get your 6 mixed proof valves. So this allows you to take any fluid from the tank and transfer it to any filler downstream independently of each other. So that gives you that flexibility in the equipment and flexibility in your process to do that. So the other thing to consider is then how do we clean this? So if you're doing a clean in place process, you want to have your CIP inputs coming in to clean the pipelines, to clean the tanks, to clean the fillers. So around the perimeter of the layouts, you would want some other valves, and typically those would be mixed proof valves. And this is where it could be a non-seat lift mixed proof valve, because when the valve opens, it's introducing the CIP, and that's when it could get cleaned. So a way to maybe take some of the cost out of it, out of a manifold, is to have your perimeter valves for CIP not have the seat lifting to it. They could be non-seat lift. So you could have a set of CIP valves going into the top of the tank, and then a set of CIP valves on the perimeter down here that would open up to return and recirculate the fluid once it gets through the line. And then another set of CIP valves that would introduce CIP to clean across this line. So the perpendicular line, in this case, it was the lower line, and it would clean that filler that's downstream as well. So again, this gives you the flexibility to clean any of these tanks, any of these fillers at the same time, while you could also still be running product in the other 2 lines. So again, this is a very basic layout, gives you a ballpark estimate of how many mixed proof valves you would need to run your core process, and then a ballpark estimate on how to clean the lines with your perimeter valves.
So it looks like 11 total valves.
Yeah.
What's the most complex manifold you've ever seen? Can it get too complex?
Well, I mean, when you have many different tanks or sources going to many destinations, yes. I mean, it can get very big very quickly. I've seen manifolds with 100 plus mixed valves.
Holy cow.
Yeah. So that you need to have some special considerations on the layout, the thermal expansion, how to maintain the valves, how to service them, take them out of the line. So yeah, it gets to be quite complex.
I heard a rumor that SPX is going to give Holland the exclusive on 100 plus valve manifolds. Those are really nice units of sale.
Really? Yeah, I didn't say that, but yeah, we'll see.
I did. Yeah. That's just all kidding aside. They can get pretty complicated pretty quick.
They can. Yeah. But I think once a company grasps onto this mixed proof technology, they want to use it everywhere, and they see the benefits on it. So it's got a pretty quick return on investment. So speaking of some real life applications, here's some photos, and you can see how big these can get. And it also shows how compact they are. So how much, the small floor space they take up. And each one of these has a control top to it. In this example here, they did include some access ways to get at the valves in the center. This one has a CIP header that would have some flush to rinse out that vent cavity. So there's a lot of different factors to it. Drain pans underneath to collect your fluids, adjustable feet on the frame in case there is some sort of tilt or uneven surface. Again, we can help guide you through that, or there's many other valve manifold fabricators that have done this for a while, like Holland, that know some tips and tricks. Here's an example of taking a PNID of a valve layout and then converting it into a fabrication drawing for a manifold. And typically, we could help out with this and pick and choose which valves are the right type, how to lay things out, and then help to fabricate that into a real manifold. So in the end, if you haven't already realized that, with this Mixproof manifolds setup, there's a much more automated way to do it, centralized control with your PLC, low probability of bad things happening. And if something bad does happen, then you have a record of it so you can address it appropriately.
Chris, we have another question from the crowd. Does SPX offer a non-slamming Mixproof? I have experienced issues with clients prioritizing cleaning drainage by piping to the top ports of Mixproof and out the bottom, which can cause slamming, as valve seat is not closing against flow.
So that's a great question, a segue into our next generation Mixproof valve that has balanced stems or non-slamming stems. So yeah, I'll show that once I show the next generation. That's a great point. With the traditional Mixproof valves that I was showing, the preferred flow direction is from bottom to top, so that when the valve does return back closed, it's closing against the flow, not with the flow, to avoid that slamming. When it goes the opposite way, top to bottom, then yes, as that person said, it can have some slamming effects. And here's some factors. Mixproof valve manifolds, they're an investment, and obviously there needs to be some justification behind that and return on that investment. So here are some of the factors that I've talked about, kind of summarized in one place, but it's really around decreasing the manual intervention, automating the process, making it more efficient, making it safer from a product and personnel standpoint, and then having it be an investment long term, that it's going to be there for a long time and be a workhorse for you. And manifolds don't make sense in every process. If it's more of a batch processing where it's pretty low volume, you're not going to put in a Mixproof manifold. But if it's a high volume where you want a continuous production process, then it really does make sense. Kind of like if you use a car traffic term of you have a stop sign in a very small town in the middle of Wisconsin, the North Woods, for example, versus in Milwaukee or Madison, you have a lot of stoplights and more automated systems to help with the higher volume traffic.
That's a good way of looking at it. I've never thought of it before.
Yeah.
Yeah.
Okay, so I wanted to talk about our next generation double seat Mixproof valve. It's the D4 series, and show you some of the differences that it has compared to a traditional Mixproof valve. This was a co-development project between our APB brand and Waukesha Cherry-Burrell brand of valves and engineers. And we do have a pretty full portfolio of Mixproof valves, going from your low-end double seal valves, which is kind of like a single seat valve with two seals to it. Again, it doesn't have that seat lifting capability, so it's used on the perimeter of manifolds in CIP applications or your really non-critical applications. And then in this end, we have our double seat valves. So this is our traditional Mixproof valves with the APB and the WCB, the W70 series. And the D4 fills some of the gaps in our portfolio as far as offering a more market competitive Mixproof offering that has the right features at the right price for the customer. And we've learned a lot in our decades of having mixed-proof valves in both APV and WCB, and we've put it into this valve, and taking the feedback from the customers and our experiences to try to make it a really good valve for our portfolio and for users. So the model range, the core models was launched in 2018. So that has your non-seat lift D4, your D4 with the seat lift actuator, and then there's this ultra hygienic DA4, which is used in more critical applications. Typically, you see this in maybe a sort of biopharmaceutical application. Outside the US, it's used in dairy because it doesn't require, those dairies don't require PMO. For the US dairy market, we do have a PMO version that's coming out actually next week that utilizes a lot of the design and features from this core model range, but also meets the very strict PMO requirements that grade A dairies require. So we're excited to launch that next week and have the D4 model range expand, and we're continuing to work on other variants, other extensions to it to make it a complete portfolio. So here's an animation of the D4. So remember what I showed with the traditional mixed-proof valve. This one's a little different, and I can point out right away to the question with the balanced stems. So having balanced stems means that the diameter of that stem is larger, both on the lower and on the upper. So you can see larger diameter of both upper and lower. So that helps to minimize the amount of flow that's hitting against the seat when the valve is returning back closed. And the other thing you'll see on this is that the valve opens downward rather than raising up. So it's a different direction of opening, again, to help minimize that slamming effect. So I'll go ahead and play this, and you can see when the valve is closed, it has that safe separation, two fluids. When it's open, it's open to one fluid and then opens downward. And when we have our product in CIP, we have our seat seals, similar as a traditional upper seat seal, lower seat seal, and then a middle seal for that vent cavity. This has a larger vent cavity than traditional. So your leakage goes into that larger vent cavity. And then you have your seat lifts, lower seat moving downward to clean that lower seal, upper seat moves upward to clean that seat seal. And then another nice feature of this is there's this spray cavity connection that cleans, rinses out your vent cavity, and that comes up from the bottom and sprays up. And that comes standard on all the D4 valves. So whether you use it or not, it's nice to have there. And if you don't use it, you just plug it. But with it being on the lower part of the valve, you can have your flush headers be in the lower part of the manifold. And because the valve is being serviced and taken out from the top, you don't need to touch that or disconnect that when you're servicing the valve. So that can just be a fixed kind of hard piped connection down there. And if you remember that other picture I showed where the header was at the top, that makes it very difficult to get access to the valve. So in this scenario, since it's lower, it's below the valve, makes it a lot easier from a maintenance perspective.
Is that just like a threaded connection, Chris?
Yes, it is. Threaded connection. Yep. So there's a longer animation on the D4 valve. I have a link to it on here, but it's on our YouTube site as well that goes into a lot of the different features, benefits that I'll talk about today. This is kind of an eye chart, but it shows some of the benefits of the D4 series and compared to our previous generation or mixed proof valves. So green check marks are good. Red X's or red numbers aren't as good. So just kind of hitting the highlights and benefits to it. It's at that more market competitive price point. It meets the hygienic requirements for the industry. It has a minimal switching leakage, so it's a radial seal design. We've tried to incorporate try to minimize the amount of CIP losses when you do the seat lifts. So the amount of chemicals and fluid going to drain, trying to minimize that. 100% hydraulically balanced. So that has to do with the upper and the lower balancer to avoid your water hammering and help protect against any pressure spikes. Talked about the vent cavity spray cleaning as standard. So both of these, balanced and vent cavity, they come as standard with the valve. Another nice thing from a maintenance perspective is there's one seal kit for 1.5 to 3 inch. So from an inventory burden standpoint, having that one seal kit cover multiple sizes is a nice thing to have.
All of our inside guys can't screw it up.
Yeah, you're more likely to have that seal kit in stock. Yeah.
I'm looking out there to see if anyone were giving me the evil eye.
Yeah. Having some integrated flushing of that shaft. So this has to do with some of the extra cleanability of that DA4, the more advanced ultra hygienic, and also the D4 PMO has this integrated into it. Another unique thing on this is the position detection. So monitoring the open close as well as the seat lift positions. In traditional mixproof valves, you for detecting your seat lifts, you have an external prox that would go from the control head into your yoke area and detect your seat lifts. With the D4 and the CU4 control top, it's all internal to the control head. So there's no external prox sensors that could get exposed to wash down or people pulling on them. And yeah, in working on valves that have the sensor in the yoke area, it's pretty finicky and it needs constant adjustment, it seems. So with this design, it eliminates all that with your seat lift detections. I'll skip down a few. Another benefit is this, the weight. So it's much lighter than our traditional WCB mixed-proof valves and much lighter than others on the market, which is a really nice benefit from a maintenance handling standpoint. This is for a 3-inch valve insert. So 3-inch valve insert being 12 pounds on this model. I mean, that's really nice. Oh, excuse me, 12 kilograms, 26 pounds, 26 pounds. Still, under the OSHA standards where you would need a lifting tool. Now, I know we all think more weight is probably maybe means heavy duty construction where it's more durable. I look at it as this is a smarter design where we're able to have the fully balanced stems allows us to use a smaller actuator and doesn't work against the flow. So it's a smarter design from a fluid dynamics standpoint where we can use a smaller size actuator. And then longer ports, so having the long port extensions for your manifold fabrication, so that you can use orbital welders on this and connect and weld a valve right next to each other, one after another in a large manifold.
It's a really big deal. Yeah.
Okay. So getting into some of the applications of the different models of the D4. And I mean, this not only applies to the D4, but other valves on the market as far as seat lift, non-seat lift, PMO. So really in general, as I mentioned with the non-seat lift mixed proof valves, they're used when that full cleanability under the seats is not required. So that's typically on CIP returns or CIP supplies in manifolds, in the CIP room of a plant where it's just working with water or chemicals, or some, like your non-hygienic soaps, detergents that don't need that full cleanability. The seat lift version is used in pretty much the other cases when you do need that full cleanability, when you need that radial seal design and you need to clean underneath those seats. And then the ultra hygienic version, mainly used in this dairy category here, where it's a critical pasteurized application, but it doesn't require PMO. If it does require PMO, then you're going to this D4 PMO on the far right, again, for your grade A dairies in the US.
If I'm a pharmaceutical customer,
Mhm.
which valve am I using?
Yeah, I think you're looking at the
There we
the
go.
DA4
Mhm.
most likely, because it has that extra cleanability to
Mhm.
it. It has that steam in place, or that you can provide that sterile barrier on it.
Mhm.
So that's probably the recommendation for pharmaceutical biopharma application.
Are the valve bodies machined or forged or cast?
So the globes are formed,
Mhm.
and then the top piece, middle piece, and bottom flanges, those are machined, and then everything is welded together in a electron beam welding process,
Okay.
EB welding process. So it's a
Okay.
mixture of
Okay.
both.
Was the 70 series, was that all machined from solid bar?
Yes, it
Yeah.
is.
So you
Yeah.
do have a solid bar
Yep.
option as well.
Yeah.
Um, your competitors, what do they usually bring to market? What kind of construction do they typically have?
Yeah, it's a mixture. Yeah, some of them do have the formed, or the casting bodies.
Mhm.
Uh, Others, it's not as common, but others do have the machined versions
Mhm.
as well.
Mhm.
So in our portfolio now we have both. We have the D4, and we still have the W70 series machine from Bar. That's not going away. We still sell a lot of those and have a large installed base. So we're still planning to continue to have that in our portfolio for the future.
Okay. What kind of, I'm going to ask one more question, then we have two questions from our viewers.
Yeah,
What surface finish can you get down to on a valve? Can you do 15, 20 RA EP?
yeah. So on the W70 series, yes, we can get down to 15 RA with the EP. So yes, we can do that. We have done that in the past.
Okay. And then Jim asks, can you retrofit a W72 valve with a D4 insert?
No, you cannot. It's really quite a different design. You start with the opening difference. It's opening upward versus opening downward.
Mhm.
So no, you cannot retrofit.
Okay. And then from the crowd here, we have, or another question from the crowd. If you could give 2 to 3 difference makers versus your top 2 competitors, they're all touting design. What sets SPX Flow's Deep Fours apart from them?
So I'll summarize it in a high value for what you get. So having the fully balanced stem and the cavity spray cleaning as standard included in that initial price, and having the ability to have that flexible flow direction from top to bottom, bottom to top. That common seal kit across a range of sizes. And then maybe it's probably a toss of, if you need that seat lift detection. I think that's a great feature and unique compared to anybody else on the market. Nobody else has that all internal. Everyone else has an external prox. If you don't need that, then I would say the next best feature that we have is the weight on it. So the weight of that insert being easier to handle because of it being a smarter design.
Here's a question from Dale Cox. Are all SPX products manufactured in the USA?
All of the Waukesha Burrell products for valves are the APV brand. The main factory for that is in Europe. But the D4 Mixproof that we're talking about, that is a Waukesha Burrell brand. It can be dual branded WCV, APV, and that is made in Delavan in the USA.
And while we're talking about that, I would like to acknowledge that the Delavan plant is still running at I think, pretty close to 100%
Mhm.
capacity.
Yep.
Everyone here at Holland we're still working hard, and we do want to thank everyone who's working really hard to build our valves and get those out the doors, because we're still trying to make it happen here. So
Mhm.
as they are in Delavan. So thank you guys. They probably don't hear it, but we'll make sure all the if you do talk to those shop guys, make sure you let them know how much we appreciate how hard they're working for us. So anyway,
it's a good shout out. There's a lot of other technical information out on our public website on the D4, on our other valve types, data sheets, brochures, manuals, animations, 3D models, which is becoming more and more popular, valve keys, so how to configure the right valve, all the different options. So a lot of material on our public websites for people to get more information. Did want to switch and talk about a few case stories.
we have one more question, Chris, that just came in. What % of Mixproof valves are mixed size, where maybe the upper body is a different size than the lower body?
Yeah, that's a good question. It's maybe 10% or less.
Mm-hmm.
I would say 10% might be a high mark. It can be offered on any of our Mixproof valves, and even on the D4, the PMO version, we're now offering that for dairy. Typically you see it in brewery or beverage, those mixed sizes. But it's a small percentage of our business. That would be a case where that is maybe a little bit outside of our standard and might have a little bit longer lead time than a standard size on size body.
All right. Case studies.
Yep. So these are also on our website. Just wanted to share a few with the D4. Here's an example of a manifold we did with a customer in Italy, and you can see, these were all orbital welded together into this very nice layout to help increase their production capacity. I think they were converting from a flow panel into this manifold to minimize the downtime for cleaning and to have that flexibility in their production schedule. And they used the 3D models, and these valves were actually produced, and the manifold was produced in our factory in Poland. Another case story involves customer in the US. So I did say that the D4 is not retrofittable into the W70 series, but it can be retrofitted into the APV series, the DA3. So you can take a DA4 insert and put that into a DA3 body. So this was a healthcare company in the US that had an installed base of the DA3 valves, and they wanted to upgrade to the new generation of D4 series. So they did that very quickly, swapping out the insert. The body stayed welded in place, and they then upgraded their actuator and control top technology to give them the benefits of the D4 series. So just to recap, it can be retrofitted into the APV Mixproof, but not into the W70 series on the WCB.
What's the smallest size that's available?
1.5 inches is the smallest size right now. We have other ideas or things in the pipeline. One of them is a smaller size Mixproof valves, but we don't see as much demand for those. I would say, as we talked about pharma a little bit before, certain pharmaceutical companies are embracing Mixproof valve technology. They're doing it more so in their CIP rooms and CIP arrays. But as we maybe see Mixproof valves expanding into other parts of pharma, or maybe more lower lower line sizes are typically used, that's when I think we'll see more of a demand for the smaller, fractional size, inch and below Mixproof valves.
Are there 3D models of all your valves available for engineers and designers to use when laying out a facility? If so, what type of 3D files do you use? And then I would also ask, where can you get them?
Yeah, so they're They're available on the public websites. If you see my screen now, this is with the D4 as an example. And yeah, they're right here under the drawings and models. If you download this zip file, it has all the sizes within this D4 with a control unit, and it's a step file, .stp file.
What if the valve I'm looking for isn't there? Then who do I call?
Yeah, you would contact our factory in Delavan and try to get routed to the applications engineering department. Or you can contact your local distributor like Holland. You guys might have a library on it, or yeah, you know who to contact in Delavan.
Yep. Very good. Cool.
And one more, another plug for the PMO version that's coming out next week. So this customer, HP Hood, and it's in upstate New York. They let us use their name in this story because they were so satisfied with the results of this the Mixproof valve. But this was their first venture into Mixproof valve technology. Again, before they were using swing panels, and it was very manual intervention. So they really cleaned up their room here for processing a yogurt and sour cream. And I think it says in here how many, it was dozens of feet of piping were removed and hoses to make a very clean layout with smaller Mixproof manifolds mounted in between the tanks. And it went from being a place where none of the operators wanted to work to being one of the most desirable places that they wanted to work, because it was all, being controlled from a central location, very clean environment, clean room. So it really boosted the morale. So in addition to boosting the productivity and efficiency of the process.
Cool.
So yeah, that's all I had to present.
I think we did have a couple more questions, Chris, that I just really wanted to touch on briefly.
Yeah.
One of the things that's been mentioned to me before is that typically with hygienic valves, regardless of whether they're Mixproof valves, it looks like I got another beer coming in, so that means I got lots more questions. Oh, this isn't a beer. This is ginger peach sparkling water. Yeah. Send that back out. Anytime that we have a valve project or a skid project, usually one of the first long lead critical path items we want to get on order is going to be the valves. With these Mixproof valves, are there configurations or types of valves that are more available than others, or what's the availability look like for the D4 series?
Yeah, I mean, we have the most common configuration is what you see here. It's the cross over the cross. But in the brochure and the valve key that we have, there's there's 2-port, there's 3-port versions. That would be our standard offering. What gets outside of the standard is your mixed body sizes, as well as anything, a 45-degree angle port, or if it's a parallel port, those are kind of, would be a special lead time, special design.
So in like, especially for me, like a skid fabricator, right? So I'm gonna buy the valves from you. They're gonna come in. Then I'm gonna wait 4, 6, 8 weeks, whatever it is. I'm gonna wait. Then I'm gonna take them apart and I'm gonna weld them. Is it possible for me to get the valve bodies in advance of maybe everything else, or separate, so I can start fabricating the manifold?
We have done that in the past. We don't like to do that because we want to test everything together as an assembly. So in Delavan, each one of the Mixproof valves is hydro tested before it gets packaged up and shipped out. So we want to make sure it is it is compatible together. In certain cases, like I said, we have done that, but it's not desirable. And usually it's not a whole lot faster to get the body ahead of time than the complete valve. So there's not too much of an advantage.
Okay, very good. Do we have any other questions out there? Because I have two more really hot burner questions I'm dying to get to. So do we have any other questions from the crowd before we go there? No, I think we're good. All right. So first things first. Last night, Chris, you're in Wisconsin, Madison, Wisconsin, beautiful town. I spent a lot of time there. The Green Bay Packers. We got a question from Dale. A real question here. Do valves require disassembly to weld, or do you need a heat sink when you're welding these?
Yeah, you should take the insert out of the body before welding it. That's the way I would recommend it.
And how about like a heat sink? I know when we weld, like when we do mag mixers and we're welding those into the bottom of a tank, we want a heat sink on there. Do I need to do anything to make sure I don't get warpage when I'm welding these valves together?
I have not heard of that. The ports are long enough or far away enough from the body itself where I haven't heard of that being needed. I'm not an expert on that fabrication process. So that's my experience.
Okay. I don't think we typically use a heat sink either. But you do definitely need to take them apart before you weld. Back to the real urgent question. What's Wisconsin's take on Jordan Love?
Yeah, it's kind of a surprise move. If he's the heir apparent to Mr. Rogers, I haven't read any responses from Aaron Rodgers. I heard he really was not involved in that decision, wasn't notified on it. Mm-hmm. So I'm sure, it'll be an interesting. Once they do meet, whenever that is, it'll be an interesting relationship that they have.
Yeah, that will be a lot of fun to watch.
I mean, the last time they picked a quarterback in the first round, he's got Hall of Fame numbers. So.
Wow, the questions are really coming in now. But one serious question we have is on your manifolds. If I bought a valve manifold from SPX, would you use round tube or square tube frames?
We actually we typically use square frames, but in the diamond orientation, so that they're free draining.
Yep. Another couple. We got a lot of Bears fans on.
Oh boy!
They want to know if Jordan Love will be able to grow as good of a mustache as Rodgers. I doubt it. Any other questions from the crowd as we're coming right up on an hour here? I know everyone else probably has things to get back to, but otherwise I'll end with one final question to give everyone a little bit of a personal background. I went to the University of Wisconsin in Madison. I was there for 4 years. Big Badger fan. I believe Chris went to Notre Dame, right, for his undergrad. Also went to Madison for business school, right?
Yes, that's right.
I was not smart enough to get into business school, but one thing we're very much looking forward to is come October 3rd, 2020 at Lambeau Field, we're going to have Notre Dame versus the mighty Wisconsin Badgers. Who is your pick to win, Chris?
I got to go with my heart. It's the undergrad Notre Dame, the Fighting Irish, pulling the upset in Green Bay, in the mecca of professional football, Lambeau Fields. I think Wisconsin's lost a lot with the running back going to the draft. I think Notre Dame's got a strong team returning. That's my pick.
We're going to miss JT, but we are going to be ready for the Irish come October 3rd. And I'll tell you what, at this point, I just hope I get to go because it's going to be interesting. So I think with that, we're through all the serious questions, and we're right at an hour, so I want to thank everyone for coming. If you have any questions, feel free to reach out to either me or Chris, and we really appreciate everyone's time. So thank you very much for joining us. Chris, thanks again. We really appreciate it, and stay safe, everyone.
Yeah, thanks for having me. Thanks, everybody.
Yep, thank you.